Hey team, today we're going over rational equations, and so we'll be doing a couple examples over them. For starters, what is a rational equation? Well, it's just an any equation, but it contains at least one rational expression. And so like this first one we have written, let's give this a try. It contains at least one rational expression, therefore it's a rational equation. Let's give it a shot. How in the world could we solve for x in this type of problem? Well, we can use an old trick, and it's called cross multiplying, because if I want to cancel out this x plus 2, I would multiply this by an x plus 2. And I do the same thing on this side. If I want to cancel out this x plus 2, I would multiply both sides by an x plus 2. It just so happens that that is a denominator in both sides, and so whenever you have the denominator exactly the same, you could just draw a nice line across them, but I won't do that. I'll show you why that works. And so right here we said, hey, to cancel this out, I'd multiply an x plus 2 here, and I do the same thing on this side. And so x plus 2 over the quantity of x plus 2 would cancel out. Same thing would happen right here, leaving you with x minus 1 equals x squared plus 2x minus 3 on the right. So now we just need to combine some like terms, go across equal sides, so it looks like I'm going to add 1 to both sides, leaving you with x equals x squared plus 2x minus 2. And then I'm left with an x on the left side, so let's subtract x on both sides. So those will cancel, 1 minus 1 is 0. So I have 0 on the left, and then I have x squared plus 1x minus 2. And so it looks like I'm stuck, but let's see if this is factorable. And so what multiplies to a negative 2 and adds up to a positive 1? Well, I'm thinking probably an x plus 2 and an x minus 1, if we could factor that. Yeah, that multiplies to a negative 2, adds up to a positive 1. That does the trick. And now we have, looks like, 2 possible answers. So we have either x plus 2 equals 0, or x minus 1 equals 0. So that would leave you with x equaling a negative 2. Or x here could equal a positive 1. Let's go ahead and check. At the very beginning in our original problem, in the denominator, we had x plus 2. Well, negative 2 plus a 2 would be a 0. Therefore, a restriction on this problem would be x cannot equal a negative 2. If we plug this number in, we get a 0 in a denominator. This would not work out. Therefore, that's not an answer, leaving you with x equaling positive 1 as your result. Let's go ahead and take a look at one more example. Alright, here's our second example. Let's say we had 1 over 2x plus 2 plus 5 over x squared minus 1 equals 1 over x minus 1. Okay. Well, this one looks like the denominator, the goal, we want to get these to have common denominators so we could cross it out in the entire equation. And so let's go ahead and simplify and see what our terms are. And so in this left fraction, the denominator looks like I could take out a 2. So I'll take out a 2. That leaves me with 2 times x plus 1. Right here, the next term, this looks like a difference of squares, so we'd have an x plus 1 times an x minus 1. Because if we worked backwards, we'd have x times x, which is x squared. Let's see, a negative x plus a positive x, that would cancel out, meaning you have no middle term, and then 1 times 1 would be a negative 1, so that's how that difference of squares works. Then you'd have the 5 on top, equals 1 over x minus 1. So we want these denominators to be common. Right now, the left side has a 2 and x plus 1, but this one in the middle term does not have that number 2, so I would multiply this by 2 over 2. And I'm not changing the value of it because 2 over 2 is that 2 divided by 2 is a 1, so I'm multiplying the fraction by 1. I'm not changing the value when I do this. I'm just changing how it looks. I'm making it a bigger fraction, so to speak. And over here we're missing an x minus 1 term, so I'd multiply top and bottom by an x minus 1. And on the right side, it looks like I'm missing a number 2 and the term x plus 1, so I'd multiply top and bottom by 2 times x plus 1 in the numerator and the denominator. Alright, so now the common denominator should be 2 times x plus 1 times x minus 1. Looks like up here when we distribute the 1, we'd have x minus 1. And then 2 times 5 would be a 10. And then on the right side, looks like we'd have 2. 1 times 2 is a 2. And then 2x plus a 2. Okay. And then the denominator on the right side we said was 2 times x plus 1 times x minus 1. And we'd have 2 times x plus 1 and x minus 1 in the right side. Well, good news, if I multiplied the left and the right side of this equation by this denominator, it would cancel out on both sides, leaving you with x minus 1 plus 10 equals 2x plus 2. Let's go ahead and combine our like terms. 10 minus 1, that's going to be a 9. equals 2x plus 2. And then when you subtract 2 on both sides, we'll give ourselves a little more space here. We'd have x plus 7 equals 2x. Subtract this x on both sides. You'd have 7 equals x, or x equals 7. And if we run into restrictions, the restrictions looks like x couldn't be a negative one or a positive one. And there are different ways to solve this problem. Say you didn't think of this x squared minus 1 being factorable, and you'd solve it a different way, and you could have had an option there where you get 3 answers: x equals 1, x equals negative 1, x equals 7, something like that. If you did like synthetic division down the road, you could get it that way, and this is where the restrictions would help you, because when you plug in those numbers, you realize, oh, those won't be solutions. You get a 0 in the denominator, leaving you with 7 as your answer. So there you have it, 2 examples of rational equations. Let's zoom out and take a look at them both. I hope this helps. Good luck in your practice.